It seems like it's about that time, so let's get started. The next speaker is Nguyen. I don't know much about wine, but I love drinking and eating, so I'm very looking forward to her presentation. The title is Food, Wine, and Machine Learning, Teaching About to Taste.
Konnichiwa. Thank you so much for having me. I'm so excited to be here, and considering you have so many choices of other talks to go to, so thank you for choosing to come to mine. I'm Mai, and first I want to say a little bit about myself, to introduce myself. First, I started working in Ruby and Rails back in 2006 at a startup in Washington, D.C., and I continued to work in Rails up till 2010. And during this time, I got interested into learning more about wine. And always, my whole life, I've loved food. So I took a break from technology, and I decided to travel and study winemaking. And I got a master's degree in winemaking at the University of Adelaide in Australia. And after I studied, I decided to pursue a career in winemaking, and I worked in wineries in Australia, France, California, and New Zealand, and that's what brought me to New Zealand. And the thing about working in the wine industry, it's an agricultural industry, so things are seasonal, things are repetitive in terms of there's a cycle and there's a way you make wine, and the wines you make need to be consistent for the particular brand you're working for. So I missed using other parts of my brain. I missed learning new things every day. So last year, I decided to move to Wellington, which is where most of the technology firms in New Zealand are. And I'm now a senior developer at Loyalty NZ, which without their help, I wouldn't be able to be here today. So I'm very thankful for that. So how did I get into machine learning? Well, it's very simple. People ask me about wine all the time, and I love to speak about it, but sometimes I just want to visit with my friends and family. There are lots of wines out there, and no one knows what they should be drinking. They always ask for advice and recommendations. And I thought to myself, there must be some way to automate this. So, just a little bit about machine learning if you're not familiar with machine learning. First, machine learning is part of this field which people call artificial intelligence, and some people say it's a buzzword that doesn't mean anything, but to me it means basically making computers do smart things. And machine learning is a piece of that in that it's not explicitly coded. It's making decisions based on models off of training data. And within machine learning is deep learning, which is basically what I think of as very layered neural networks. And it's basically machine learning on machine learning on machine learning. And it relies on a ton of data. And across all of this is natural language processing. So you can have natural language processing that's based on machine learning or not. Could be explicitly coded or with model-based logic. So now we know where machine learning fits in the realm of AI, just a little bit about what it really is. Machine learning does not rely on coded rules. It creates its own models based on training data. And so the training data, it can be supervised or unsupervised. Supervised meaning your training data contains the right answers that you want the machine learning algorithm to predict upon. Unsupervised means there are no right answers and you're just asking the algorithm to find those hidden structures and patterns within that data. And of course, there are many types of algorithms for many different kinds of problems. This is only a 40-minute talk, so I won't get into all the algorithms. But what can machine learning really do for me? Well, I think of it as you can take any kind of infinite combinations of inputs and you throw it at your machine and you can get a finite answer, be it a Boolean, a number, a category, etc. So what are some common use cases for machine learning? A very, very popular use case is classification. You can use it for spam filtering, categorizing sentiment, recognizing fraud, ad targeting, and medical diagnosis. Another popular use case is recommendations, which we are all familiar with product recommendations. But you can see that it could be also used for job recruiting, dating websites, and also recommending content, which you can see when you log on to Netflix. You can use machine learning to also predict things, including the stock market. You can predict demand. You can forecast the weather. You can figure out when the Carps are going to win another game. You can use it for inventory and asset management. And the last use case, which I think is really important, is imputation, which is basically using machine learning to help you in your machine learning data sets to fill in missing values. So some basic features about machine learning that might not be intuitive is one, the accuracy improves as you collect more data. You can automate it by having it learn automatically as your answers are validated. You can make it go fast depending how you've configured and the type of algorithm you're using. And it can be customizable based on your own data. And you can also have it scalable. So why aren't you using it? Well, there are lots of reasons people might not be using it, but I'm going to introduce some reasons that people might be using and why I think they're not great reasons. So one is I like Ruby, and I don't want to write Python. And I agree with this. I don't know Python, but I'm using machine learning, so that's a terrible excuse. One, I don't have time to learn these algorithms. Yes, we are very busy people, and there are people that have spent a lot of time as data scientists studying and researching and developing algorithms. Let's let them do their job, and we'll just consume things. So amongst Ruby resources, so you don't have to write in Python, we've got lots of algorithms and tools ported to Ruby. Not a full set, but a good amount at sciruby.com. And yesterday, Kenta Murata gave a great talk about PyCall, which is calling Python from Ruby. And of course, that would require you to be familiar with the Python libraries. So you don't have to code in Python, but you will still have to read their documentation. And also on these two sites right there, on that GitHub, are lists of machine learning gems and other natural language processing tools that you can check out. And these lists are growing all the time. So if you checked out machine learning a year or two ago, you might find that the tools that you were looking for could have been ported over, and you might be able to still pursue machine learning in Ruby. Additionally, there are lots of machine learning APIs and services. So you can just call somebody else's work and let them do it for you, and you don't have to be a data scientist, and you don't have to get into the nitty-gritty of algorithms to be able to use machine learning. And the benefits of using these cloud services is you also don't have to worry about the infrastructure, the DevOps, and all of it. You can have it auto-scaled, et cetera, et cetera. So BigML is one of the first cloud-based services of machine learning. And of course, Amazon has moved into this space with 2 regions, and you know it's Amazon, so they're going to expand, and it will be available in other places too. Microsoft the same, and we've got Google Cloud Machine Learning Engine as well. And if you're interested in TensorFlow, there has been a project to port it to Ruby if you are interested in using that. And of course, there's also a lot of natural language processing APIs and services. Wit.ai is a popular one specifically for chatbots, and Facebook owns that one now, so it's integrated with their messenger apps. And there's Microsoft Language Lewis API. Monkey-learn is another one, and Google Cloud Speech and Natural Language is for voice and text. And they also own API.ai, which is another chatbot-oriented natural language processing service. And Amazon, of course, we all know about Alexa. And IBM Watson API, I put it on the list because they're a player, but they're quite expensive. So if you're doing it for a hobby, I don't think it's cost effective. So now that we know we have some tools that we can use, that's great, but how do we use it and where do we start? So what are the first steps? One, we need to think of the question that we want to answer. And that's really important because it will guide all the decisions that you make here on out. And if you're not sure about the question, also you should think about the data that you might have access to. So, because if you don't have the data, then you can't really use machine learning to solve your problem. So about the data, you can use your custom data, which is data that maybe your company or you yourself have been gathering, or you can use free public data, and there's so many sources for public data. UC Irvine Machine Learning Repository is a big resource for free public data sets. Kaggle.com, they are a big player in the data science space in terms of they host a lot of competitions so that you can try to test your data science skills, but they also have a lot of free data sets. And then the list goes on and on. A lot of government facilities and municipalities will have data about census information or geographic information, weather information, et cetera. Whatever question you want to answer, you might be able to find that data for free if you just look. So we've got lots of data, but it's important that the data is good quality. So what makes good data? Well, number one, it should be representative of future data. So if you're trying to predict something, the data that you have needs to be similar to the current conditions so that your model that's trained is trained on what it should be predicting on. Second, it needs to be complete. So that means no blanks. So if your data is from user surveys and they just prefer not to answer how old they are, you need to either fill in that data or take those surveys out, because having a non-answer in your data set is only going to introduce noise into your machine learning. You need to have relevant features with minimal noise. So what I mean by that is, let's say you have a data set of user information. Maybe the user ID that you have in your primary key of your database is not relevant to the user behavior of that user that you want to predict. And also, you need lots of data, and the more data, the better. So let's talk about how we can make our data better. So there's this one when you're working with machine learning, you'll find that you're going to spend a lot of time working with your data, and they call it feature engineering, which is basically transforming the inputs that you have into predictive features that you can use to predict on. So for instance, maybe you're collecting date of births, but you don't care that someone was born on March 14th. You care maybe about that they're between the age of 20 and 30. And so you need to change your data to reflect that, because you want to make sure your data is as relevant as possible. And then also, I keep mentioning this, but this is so important, you need to fill in missing data. So there are several strategies you can do to do that. You can impute with adjacent data. So for instance, if you have time series data, like weather, temperature or something, and the weather sensor has an outage periodically, maybe you can fill it with the data next to it, or the data after, or the average between the the sorry, the mean or the median between the endpoints that you might have the information for. And then also you can use machine learning to make an educated guess. Oh, also, it's also important to use the inputs that are relevant. So I put an asterisk next to it because the beauty of machine learning is it will find patterns that might not be apparent to you as a human. And so if the machine will find patterns that you might not be aware of, you might also not be aware of which inputs you have that could be relevant for your machine learning. So there may be a situation where you need to do some trial and error to figure out which pieces of data are relevant for your machine learning algorithm. So just now that we have good data, or we have our data, let's talk about what we do with it. Well, first we divide our data into two pieces. The biggest one, maybe 80% of your data, you would use for training, and the remainder you would use for evaluating or testing your models. So you take your training data set and you put it through your feature engineering, your changing the inputs, getting out the irrelevant information, and then you send it to your model to be trained on. Similarly, you take your test data set and you also put it through the same feature engineering pipeline that you've got, and you send that to be predicted and evaluated. So, oh, I didn't realize my mouse was there the whole time. You basically, evaluation is comparing what did your model predict and what is the real answer that you expect. And based on that, you can say, oh, it's not that accurate. I need to change something. So we can think about how we want to optimize it. And you do that by tweaking some tuning parameters, or you evaluate whether you need more training data, you have some edge cases that you've missed, et cetera. And so then it becomes a cycle of training, evaluating, optimizing, and continuing on that until you have models of the accuracy that is good enough for you. So for predicting, it's quite simple. You take your new data that you want to predict on, you send it through the same feature engineering pipeline, preparing the data, and then you send it to your model to predict, and you get some results. It's that simple. So now you know a little bit about why, or the steps, the process of creating better models and working with machine learning. But there are instances where you wouldn't use machine learning, and it's important to keep that in mind as you're working. One is when the rules are known, well-defined, and finite. For example, if you are in the business of selling school uniforms, I don't think you need machine learning to tell you that you should advertise to parents of children in school. But this makes sense. It's well known that people that are going to buy school uniforms are people with children. You don't need machine learning for that. Simple. Another instance where you might not want to use machine learning is when you require very, very high accuracy. And that changes a little bit with deep learning, but in general, machine learning, you don't want to put life or death situations based on predictions. And also, if the data is unavailable or difficult to obtain, maybe machine learning is not for you. And with machine learning, there are some challenges. One, mistakes in training data can be hard to spot. Meaning, let's say your training data is surveys. How do you know that the users that are filling out the surveys aren't lying or making mistakes? You just have the data and you really have no other choice but to work with it. And it will affect how your models train. Just to keep that in mind, it is a challenge. It's also a challenge if you need 100% accuracy. That's really near impossible. And testing can be difficult, especially when there are lots of edge cases, and you need to have the training data that covers those edge cases for your models to predict on these edge cases, and it can be challenging. And as I spoke before, future data, if your topic or question you're trying to answer is constantly changing, and the future data might not reflect past data. For example, house prices. You might have historical house prices and you want to predict house prices in your area, but then there's a sudden house boom in prices and prices go up and you want to, then suddenly your models are not accurate anymore. Another thing is biases in your training data can be magnified. So that means that if you have data that is missing certain segments of the population just because you don't have that data, it may have unintended effects on how, when your machine learning encounters those other unexpected data. I won't say the example. There's an example that's quite well known where I think Google was doing some facial recognition software and they didn't have very many black people in their data set, and so it recognized black people as gorillas, and that's not good. Not good. I think they fixed that. So, lastly, determining whether your machine learning prediction is successful can be challenging. For instance, you watch a movie and Netflix gives a recommendation for something else to watch. How does Netflix know that that was a good recommendation or not? Because maybe you didn't click on it because you've already seen that movie. It's difficult to gauge. It's a challenge. I mean, there are ways to try to get around, but that can be difficult to figure out, is your recommendation good or not? So that brings us to a practical example, which kind of summarizes a lot of these challenges. So I built a Happy Wine Bot, and the problem I was trying to solve is that average consumers find wine intimidating and don't know how to select wines for their meals. My solution was to build a chatbot that would be online and available whenever, and it will educate, entertain, and match wine with food. So to build this, I need my chatbot, Happy Wine Bot, to be able to converse with users to answer questions. It needs to understand tastes and flavors of food. It needs to understand tastes and flavors of wine. And it needs to be able to evaluate food and wine combinations for good matches. So how do we teach a chatbot to converse? Well, I first explored AIML, which there's a gem called Programmer. And I found that it was, AIML is Artificial Intelligent Markup Language, and it's basically an XML-based vocabulary dictionary, kind of using regular expressions and things and keywords to basically recognize phrases, and then you give a response to it. And it's just when you have a large vocabulary and a lot of things you want to respond to, these XML files get crazy, and it's just too much, not ideal. So then I explored some natural language processing API services and looked at a few, and I settled on wit.ai because it was free, so that's awesome. And I integrated with Twitter, which is a poll mechanism. So I have to check every few minutes or whatever to see, are there tweets for this account? I also integrated with Facebook, which is a push mechanism, so it's using webhooks. And I had to spend a lot of time working on the chat content, which will be used to answer questions. So tick, Happy Wine Bot can talk. Awesome. Next, we need to talk about taste, tasting food. So first, let's talk about taste. So we know taste is about our tongues, and we know that there's basic tastes like sweet, salty, sour, bitter, umami, fatty. Fatty is a new taste that the scientists have come up with. And also, your tongue can sense physical sensations. So that includes texture, weight. Also, there's pain receptors in your tongue, so those are activated when you eat very spicy, chili foods. And then, of course, you have your nose. And depending on what science articles you're reading, it can detect between 10,000 to 1 trillion smells. So a lot of smells, and those combined with your tastes on your tongue make flavors and tell your brain how food tastes. Or anything tastes. Could be wine as well. So what are some features of food that affect taste? Well, we've got ingredients, and those include herbs and spices, and the proteins that might be in the food, whether it's fish or chicken or beef or eggs, what have you. And you have the cooking method, which can influence taste, which is like if it's grilled, then you have those charred flavors. If it's slow cooked, maybe the texture will be softer. So these ingredients and cooking methods, they affect your taste, your flavors, your texture, the weight and intensity of the food. So when we talk about teaching the bot about food, first we need to talk about training data. And it looks like ingredients and cooking methods, that sounds like a recipe to me. So I'm going to use recipes as my training data. And the recipes, there needs to be very complete and detailed. There also needs to be a lot of them. So we've got lots of online recipe sites, and I'm just scraping the relevant parts that I feel are the recipe. Obviously, lots of sites have ads and other things on the side, so I'm just scraping the parts I need to make my data as clean as I can get. And so the different flavors and taste attributes become the features that I want to predict. So I'm using my own personal cooking experience to generate some supervised training data. So models that my machine learning is using. So I'm using text classification, and I'm using one classification per flavor or feature. So one for sweet, one for salty, one for sour, etc. And the features that I'm predicting are chosen specifically for their interactions with wine. So if there's a feature of food like, I don't know, maybe, I can't think of one. Only specific flavors that impact wine are the ones I'm looking for, because my list of features was getting out of hand. I'm identifying 50 plus features per recipe at this stage, and that's really me taking some shortcuts as well. So here's a little bit of a classification example, just so you have an idea of what I've been doing by hand for my supervised training data. So imagine you have a hamburger, someone wants to know what it tastes like, you want to tell the bot how it tastes. Well, you can analyze the ingredients and the cooking methods to figure out the different types of tastes and features that you think the bot should know about. And so this is just a start. This is not 50 of them, but there you go. Salty, sweet, sour, bitter, umami, soft, from the different components of your hamburger and how it's cooked. So we've covered how to train the bot to understand food. And now let's talk about wine. So there are lots of features of wine that affect taste. So you can look at the climate that the grapes were grown in, the grape varieties, viticultural practices, including harvest decisions. There's winemaking decisions that, like, do they use this type of barrel versus that type of barrel? Do they use this type of yeast, et cetera, et cetera. There's oak, there's stylistic decisions, and of course the age of the wine impacts the way the wine tastes. And obviously these factors contribute to the viscosity or weight, the flavor intensity, the tannins, acidity, sweetness, bitterness, and of course, the aromas and flavors of the wine. So how do we teach the bot about all of this? Well, we need wine data. Unfortunately, wine data is not so consistent across different wines. The wine reviews can be kind of incomplete or short or inconsistent. You can't trust everyone's judgment of what a wine tastes like, because there's a lot of people with differing opinions out there as well. So for now, I decided to focus on general categories of wine, and I decided to rely on my personal experience and knowledge on different kinds of wines, and as well as some wine literature. And so I just came up with, just myself, with 100 plus different types of wine, and I've codified them with 40 plus taste and flavor attributes that influence how food and wine should go together. So that's how I've taught it how to understand tastes and flavors of wine. And so now how do we think about evaluating food and wine combinations for good matches? Well, first let's think about what makes a good food and wine pairing. So there's one instance where the wine enhances the food, as in the wine makes the food taste better, but largely the wine is unchanged by the food. There's also instances where the food enhances the wine, which means that the food's largely unchanged, but the wine tastes better as you eat it, as you drink it. And then there's the best kind of wine pairing, which is where food and wine enhance each other and they transform each other and they become a whole new good, great, awesome experience. So there's some strategies that sommeliers use to pair wine and food. One is matching flavor intensities with and weights of the food and wine together. So an example of that is you think about a big, rich, fatty steak. You can pair it with a heavy, bold red wine because they're both flavorful and heavy foods. Another strategy to pair wine and food is to think about the basic tastes and complement them for harmony. So for instance, sweet wines would probably go pretty well with sweeter foods. If you have a sweet food and you pair it with a dry wine, that wine will taste very acidic and harsh and sour. So you want to keep those flavors in matching. Another strategy is to match and contrast the flavors and textures of the food and wine. So you can match a herbal food with a herbal wine, and that can combine to create a new experience. Or you can think about, say, a sparkling wine has all that carbonation, and that might go well with a crispy food like a fried tempura, etc. Another thing you might want to think about is that the origin of the cuisine and the origin of a wine might be good to go together. There's a common saying amongst wine professionals is, what grows together goes together. So lots of people try to match wines according to geography like that. And lastly, but not least, you want to avoid problematic combinations. And so there are lots of problematic combinations, but one example is a very spicy, chili, hot food might not be great with a very high alcohol red wine because that alcohol also burns and just augments the spiciness of food. So if you're eating something really spicy, a high alcohol wine will make it taste spicier. So don't do that. So how do we teach the bot to do this? We've got wines, it knows about wines, it knows about foods. How do we teach it to recognize good wine pairings? Well, food and wine matching is inherently rules-based, and looking at it, the rules are pretty well defined. So ML is not necessary in this case. So I relied on my previous knowledge and experience and wine literature to build a weighted scoring engine so I could rank different wines against the foods. And, oh, demo. Okay, so here's a demo of the bot. And is it playing? Is it playing? Okay, yes. So this is the bot on Facebook. So we're clicking on Get Started, and we're zooming in because it's very small to see. And we can first try to ask or say hello. And the bot responds because it's live, and you want to chat about wine. And do you know any jokes? And it's not a very good joke, but it's a joke. And we can also ask it another question. And this is using natural language processing API just to be able to recognize the different questions and intents of what people are asking it to come up with answers. If you ask it something it doesn't know, it will tell you it doesn't know, just like Siri or Alexa. So we're asking for a wine match now, and we're putting in karaage, which I think is delicious. And so it gives you a link where it will put its wine matches. So we're opening that in a new tab. And my partner and I worked very hard on this picture, so admire this thinking robot. And while it's doing this, it's getting the recipe and it's evaluating it against my 50+ taste of food models, and then it is taking those and comparing it to the wine types that I've got, wine categories. And so it's got some recommendations now. And so we'll zoom in a little bit so it's easier to read. And so these are some of the wines that's recommended. So karaage, like I said before, is fried, so it goes pretty well with sparkling wines. And then we also have a light-bodied red wine, Pinot Noir, which goes well with chicken, lighter proteins like that. And it also gives you some general wine pairing advice. And there's a link if you don't like Facebook, you can ask for wine pairing advice there by typing another dish. Cool. So I learned a lot building this bot. Some of the things I learned is it's very time consuming to generate data manually. And sometimes you don't have a choice though. Chat content took a lot of time to figure out what I wanted to look for and answer, and the recipes took a lot of time to codify into the different flavors. The wine types and attributes, figuring out what wines I wanted to give as options, was another one that took a lot of time to research and figure out what categories I wanted to include for my MVP, because it is MVP. There's many more than 100 types of wine. So this is just a good start. Another thing I learned is you can never have too much data. And I found that in my models, because I'm training it with recipes by hand, I cannot give it thousands and thousands and thousands of examples of training data. And working on that accuracy with limited data is tough. And people say many unexpected things to bots. And just a little innocuous example is one of our friends tested the bot, and it can't recognize misspelled words at this stage, so it does not know how to respond. So what are some takeaways I want to give you from listening to this? One, machine learning can do so much. It can answer so many things. And there's so many options to use machine learning in your Ruby stack, so please don't let that stop you. And quantity and quality of data is very, very important. So what are you waiting for? Give machine learning a try. Thank you so much. Arigato gozaimashita.
Thank you so much, Mai. There is no time to left.
I'm around. I'm here all night.
Please ask her after this session.
Thank you.
Thank you.